So, and this is the big one. So talk about processes, Tim.
So one of the things that we run into is deviation. I mean, every process really has a deviation, or what we call here an inconsistent process will lead to inconsistent results. And so what you try to understand, though, is where the source of variability is. And in this case of the coffee, our raw material that we're calling is the coffee bean, So you get this picture here. You got different sizes of the grinding of the bean, different sizes of the beans. And really what that's coming down to is affecting the flavor or quality of the product that you're, in this case, obviously the flavor of the coffee. And this is one of the things you do find when you batch as well. You can run into these issues, and it takes you a longer time to see those issues when you're batching.
Yeah, and in this case, if you look at the beans and say, well, it's not that big of a deal, but the same principle applies in anything you do. So if somebody has, you mentioned the epoxy earlier, and if the epoxy is contaminated, or if you get some problems in the process about how thickly or thinly it's applied or how long it's left to sit, what happens to your product?
Yeah, well, what we'll have to end up doing is sorting through those depending on what we think the issue is, or even possibly getting rid of the entire product. In this case, it's a linear product, so sometimes you have a rework step, possibly where you can cut, the suspect area out and try to rework it. But again, these are all non-value added tasks that we'd be doing, so we'd be looking at how we could try to control and reduce the variability of the incoming material.
Well, we'll talk about, you mentioned linear process. That's just an interesting term. I'm not sure if everybody's familiar with that.
No, for us it would be typical process for wire and cable. It's an extrusion, so instead of making eaches, it's linear feet of material. And so we process products that way, and then we do eventually get to an each at some point, but it's a continuous process flow, a chemical process of some kind, whether it's extrusion or glass making, but that's what we're talking about when we're talking about linear processes.
Well, I could see how if you have a problem somewhere along the way in that process, or some inconsistent material, it'd be hard to find it too. And if you're putting thousands of feet of cabling out, you have to find that point in the cable where it's bad, especially, and it's probably even harder. Every time a problem makes it a step further down the process, it's more expensive to fix. So imagine if that cable gets put into somebody's, into underground, if it's underground and routed to neighborhoods, and then you have to pull it out. That could be a big problem and a lot of expense associated with that.
Right. Same thing as brewing the 12 cups of coffee here, in the case in which you would collect a large pot and you don't know where the flavor profile is throughout the pot. And you may have this issue when you do that, but you won't in a single cup. It's isolated to a smaller quantity.
Now, this inconsistency we talk about, there's one is a process that's not capable or not stable. It's a process that doesn't provide that systematic, the same results every time. So it's a process problem. But then you also have the problems of an individual not following the process every time, or different individuals having their own processes. And you see that a lot in the office, where you have 10 people all doing the same job, but each one does it slightly different.
Yeah, I agree. You often do see that in the office because the people are more intimate with the process than they might be in some of the manufacturing steps in a process, but where they're more machinery and automation there. But you do run into that. It's the same process by which you're getting the variability. It's not the people. Again, it's the system creating that variability.
Yep. So to improve quality, there's a couple ways you can do it. We like to build quality in. So, and that just means that the system can't make the mistakes like Tim's talking about. You can't have a mistake come out of the system. And we'll talk about some of that mistake proofing in just a second, but I wanted to talk about something here first. And what this is, these are both gauges. So Tim, talk a little bit about gauges and the difference between a gauge and a mistake proofing device.
Sure. I think this is really one of the first elements in the visual factory. This is kind of the visual factory example for the coffee pot here, where you got these, signals in front of you, and that's really what you're trying to do with visual factory. So this case on the left is really, a gauge, and the fact that it's a waste collection unit underneath the coffee for spills, and it reaches a maximum level, and kind of this float, this red level indicator pops up and says, I need to be changed. Versus on the right-hand side where you got this and-on light like you might have in a manufacturing process of some kind, which is a visual indicator of the status or maybe an error message of some kind in the process.
And this is as you start putting in these kind of gauges, gauges are better than nothing. So they're a step forward in this whole thing about building quality, getting good quality in your output. And the one on the right is fairly sophisticated. There's obviously some kind of computer interface in there and a sensor, and that one can be pretty hard to put in a process on your own. But on the left, that's just a mechanical float. And if that didn't exist there, it'd be pretty easy to go and use some trimmers and cut a piece and put a little plastic float in that waste bin. And I think that's something that people get a little bit reluctant to do is to modify things. And of course, whenever I say modify, I always like to say, make sure you do it safely and you're qualified to do it. But we have this functional fixedness that we don't want to change anything that an engineer at some other company designed. We don't want to go and put in these new gauges or any other type of devices onto this machine. But creativity is, your team is going to have some great creativity in it. And these kind of devices are really easy to put on. Simple devices, markers, and any type of thing like that. You can really vastly improve machines in the application that you're using by putting gauges into them.
And I think the important thing to note here is that you're trying to build quality into the process. You're not trying to catch the quality afterwards. You're trying to put it in as you're brewing the cup of coffee. So this issue with overflowing, or are you set the right condition? So in this case, you have those visual indicators to help you with that. And this is a perfect lead-in for kind of where we would go next with these visual indicators, and that's trying to make the job easier. And what we're really talking about is this Poka, Yoke, and Jidoka. Why don't you try to tell us a little bit about that, Jeff?
Well, this goes back to the whole thing about people again. And, coffee is typically drunk early in the morning, and it's when you're not really at your sharpest, especially if you're a coffee addict like myself and you need a couple cups to get going in the morning. The problem is you haven't had your coffee yet and you're trying to brew it. So in this image here, that little ball that's hanging down is a spring-loaded mechanical device that if you happen to pull the pot out while it's still brewing, you won't make a big mess. So it prevents people from having to make those errors that consume their time, their resources, create frustration on the job. So a device like this is a very simple mechanical Poka Yoke that prevents an error from happening. It prevents you from spilling coffee directly onto the hot plate and sizzling it or wasting it. And these types of devices are fairly simple, but again, you can go into some more sophisticated devices also. And this is in the tank. And there's a float in there, and this is a mechanical float that must have a magnet below it that tells the computer to flash the light. But this is different from the light a couple places to the left with the hopper for the discarded coffee grounds. This light actually it indicates that there's a problem and tells you what problem it is, but it won't let you actually run the machine when that light is lit. And this is the transition. You start taking a Poka Yoke and turning into this concept called Jidoka, where the machine has some of that intelligence built into it. So the concept here is the machine prevents you from making a mistake and somehow notifies you. And there's a whole Jidoka cycle that follows on this. So Tim, what happens once you get that light lit and the machine stops? What should happen?
Sure. I think the important thing at Jidoka is the stop work. I mean, that's the real important thing. So, the real key elements in this case is you have a visual indicator. It stops the machinery, so you cannot inadvertently use it without water and damage in this case, you would potentially damage the heating element used to heat the water. So this is an important safety interlock, but that will prevent future quality issues from the machinery breaking down. And so in this case, you stop the work, you fix the problem, and in this case, it's a manual intervention to add water to the coffee machine, pot tank. But again, I think if you want to have some further clarification on some of these terms like Jidoka, Jeff offers a really great continuous improvement companion, and you kind of see some of the definitions within the lean terminology that you can go and reference later. and you'll see where you can access that at the end of this presentation.
Oh, thanks for that, Tim. But talk more about the next step on this. So the light gets lit, and since you're doing this, I'm working on this as an external consultant now, and I do a lot of the publishing and production. But you're actually down there in the trenches right now, and you're working with people who have to deal with these problems, right?
Yeah, this is in a case where you would, possibly bring in a team. You may have multiple, people involved. This is a relatively small example, but you may have a larger example. But basically, you're in a lying down situation, and the importance is you've created the urgency to fix it because you are stopped, and so you should try to get that obviously rectified as quickly as possible. And so there's, multiple steps you can do, but, the simplest one is the plan, do, check, act, and you do your problem-solving approach as to what is it, how are we going to work on the countermeasure for that. Okay, we implement this countermeasure, what's going to be the check that we're going to do to make sure it's working, and if that doesn't work, we'll adjust. And so it's a simple problem-solving methodology that everyone can use, really no matter what size the problem is. And so that's one of the approaches we would take.
And you mentioned the PDCA cycle, and I think one of the really, the critical things in any kind of real production situation is having it clearly defined whose responsibilities, who has what responsibilities when the line actually does go down. So you can imagine if you're a worker on the production line, and you pull your andon cord and your machine stops and there's flashing lights and buzzers going on, and fixing it is beyond your capabilities, and you're pulling and the cord and nobody comes. That's that the failings of many companies is they have an andon light in place, but they don't have the system behind it. They don't have the infrastructure behind it to respond quickly and then actually do those things that Tim talked about, the countermeasures. Once you deal with the immediate urgent problem, you have to figure out how to keep it from ever happening again. And that's that's really one of those big differentiators between companies that dabble in lean and companies that really get it. And the ones that really get it, they track those problems. They figure out why somebody came, why somebody had to respond to an issue. They track that, and then they go after the big ones and keep them from ever happening again. And they go through that countermeasure process or get the A3 process going. But they keep these.
Yeah, I agree. I think the important thing here to note is that you have to have a defined help chain, in your process. So you get this first indication. Is this something that the person, the operator brewing the cup of coffee can address or not? If not, what level does that go to next? How long do you wait before you bring it to the next level until you get the problem really resolved? It may take the entire organization, depending on the size of the problem, to be involved. But at these levels, you have these indications of where you need help, and it's predefined how long I'm going to wait, how long I get to troubleshoot myself before I go to the next level of support. And that's really what you're talking about, is this defined help chain or support chain in your process.
Exactly.